Hi, in this video we are going to talk about vectors in C++. So why do we need vectors? What are the problems with normal arrays? Normal arrays work great, you can have an array of some size. You can have an array of variable size also. You can have an array which is dynamically allocated, so you can remove it and then you can delete it. Right? If you do not need the space, you can delete that and then you can create a new array, and then whatever you want to do with this array, whenever you need it you can allocate, whenever you don't need it you can deallocate. We have all these things available. What are the problems with these things? Why do we need something like vector container, right? So the problems with these things are, consider a situation where you want to build a software for college. College tells you that we are going to have these many admissions, say 500 admissions at the most. Now, if you are storing these student information into an array, what you will do? You will create an array of size 500, right? Or if you want to save space, you will say, okay, tell me the current number of students, and you will have the array of size n, like this or like this. The problems with both the approaches: you are wasting space. In the first case, you are creating an array of size 500, and it might happen that actually students admitted into the college are 200 or 300 or 400. 100 addresses, 100 elements are wasted. In the other case, when you say tell me the number of students, it's not possible to know the exact students because you need to pre-allocate the memory. For example, somebody says, okay, there are 300 students, and then n is 300, you allocated an array of size 300, and then more students got admission. The count went 400. What will you do? Your array cannot accommodate those many extra students that joined later. One more situation might happen is some students might leave. So you have 300, it might become that only 200 students are there at any point. So these are the problems with the arrays. We always end up wasting space by allocating extra memory. It's not dynamically changing size. That's where vectors come into the picture. Not only this, so this is one point that I just said. Dynamic size is the main point though, but there are more advantages of vectors. So we're not talking about the problems now, we are talking about vector advantages. So one is dynamic size, which is not there with the arrays, right? You have a fixed size pre-allocated array. Other is rich library functions. You have a function to find an element, you have a function to erase an element from the middle, you have a function to insert an element in the middle, and many more functions. There are plenty of functions on vectors which might not work on normal arrays. Here I have written a list of advantages. These are just the most important. There are many more advantages actually. So the third advantage is easy to know size. In case of arrays, if you want to know how many elements are there in the array, you will have to do all this. Size of ARR divided by size of ARR 0. Or maybe the data type of the array, size of int, if it is an integer array. In vectors, if v is the vector name, then it's just v.size. The next advantage is no need to pass size when you pass it to functions. When you pass arrays to functions, what happens? Arrays are always received by functions as pointers. Even if you write a square bracket, this is just a pointer. This is same as writing star ARR. So if you do this inside this function, to know the size, you will get the size of a pointer. So you must pass n as a parameter if you are using normal arrays, but that is not required in case of vectors. Vectors are actually objects of the vector class, so they have size inside them, and you can do just v.size inside any function to know the size of the vectors. The next advantage of vectors is they can be returned from a function. If you try to return an array which is locally created inside the function, this is an invalid function. because this address is not valid once the function call is over. Once the function call has returned, this space is deallocated for the array. This array goes out of the picture. So if you're returning a locally created array, it's an invalid program. However, you can return a dynamically allocated array. This is fine. I mean, when I use new int, this is fine. But in case of vectors, you can simply return a vector. I created a vector here, say I did some processing and I simply returned it. It works fine. The next point is, by default, vectors are initialized with a default value. So if you create a vector of integers, and if you have specified the size, say 100, then all the 100 elements will get 0. If you have created a Boolean vector of size 100, then all the values by default will get false. Similarly, empty strings, if it's a vector of strings. If it's a vector of floats, again 0. So the default value, something like Java, it happens with vectors. Since arrays, you have random values. You don't know anything about those values. And what happens many times when we write programs, we first create an array, then we initialize it with 0. We don't have to do it in case of vectors. That saves our time. The one point that was missing here, we can copy a vector to other. This also saves time. So in case of array, if you have to copy one array to other, you will have to run a loop, right? Or you will have to use some function. Here you can simply write v1 equal to v2. It does copy all the elements of v2 into v1. And that is what was happening when we were returning a vector. A new vector is created and which is returned from this function. So these are some advantages. This is just a small list. There are plenty of advantages, and you will realize many advantages when you use vectors, when you start using vectors in your programs. They save a lot of time compared to using arrays.